What say we uncover some mysteries of space together? It's time to take an inside look at the interiors of planets. We start with question 1. What do gravity, density, and inertia tell us about what's inside planets? Let's start by discussing gravity. Everything has it and everything else feels it. Gravity pulls things together. Here it's symbolized by this picture of an apple. Everything in the universe has gravity, but planets are the most famous for having it. They have gravitational fields that attract satellites like, say, moons. Gravity is measured with field lines, and, according to Isaac Newton, gravity increases with mass. Now we move on to density. That's our idea of weight and a planet's idea of how tightly packed its mass is. Density determines what can sink or float in a material such as water. Saturn would float in water. Amazing. Unlike Earth, which is the most dense planet in the solar system. Note that different elements have different densities, and that is a major key in determining what elements are inside a planet. Next we have inertia. Inertia is why objects need to be acted on by a force to start or stop moving, i.e. rotating. You may have heard that in Newton's first law. A moment of inertia, for a planet, means how its mass is distributed, which then means that inertia can lead to figuring out the size and density of the layers inside any given planet. Question 2 is, what is a dynamo and how does it get started? Let's start by asking ourselves, what's in a planet? Usually planets are made of a core, mantle, and, if there's any solid, crust, which means the giant planets lack crust because they're mostly just gas and liquid. Earth, however, has a core, a mantle, and an outer and inner crust. The insides of planets are made of different elements, and their insides can be either active, like Earth, or dead, like Earth's moon. What's the definition of dynamo in this context? Well, in space, a dynamo is what creates magnetic fields. The sun's dynamo gives it a very famous and powerful magnetic field. The moon, however, if we're speaking about Earth's moon, has no dynamo. The power of a dynamo is electrical. And note that some planets have dynamos and some don't. I'm looking at you, Venus. I'm also looking at you, Mars, because it's time to move on to the third question. What is this inferring about the strange histories of Mercury and Mars? The red planet used to have a dynamo, so why doesn't it anymore? Its dynamo was lost because iron and sulfur separated in its core, and solar wind robbed it of its atmosphere and took care of the rest. This, say the scientists, could be because of a giant impact, much like the one that caused Earth to have a moon. Why does Mercury have such a big core if it's such a small planet? The core is made of iron and nickel and is 85% of the entire planet's volume. Yet somehow, the magnetic field of Mercury is very, very weak. And scientists have said that this is probably also caused by a giant impact. Amazing. What can we learn from all of this? There's a lesson here somewhere, but what is it? Well, the three main things that I learned are these. 1, we can find out so much about our huge universe without leaving Earth. Number 2, the laws of the universe, science, physics, astronomy, chemistry, can be our guides and tell us so much. And 3, the solar system was born out of violence. The early solar system was a very chaotic place with many bumps and collisions that eventually shaped our relatively calm and peaceful solar system. And that marks the end of this presentation. Goodbye.